We are back. Thanks very much for being here today. So we had I'm just going to reiterate what my colleagues said before, very interesting panels this morning to kick off the day. And now we're just going to have a deep dive into technological innovation to see how we can address some of the challenges that were raised, in fact, that have been raised over the last 2.5 days. And without further ado, I would like to introduce here to the stage our first presentation, Matthiesen, Head of Sales at NextGen TKMS. He's going to present PROACT, a proactive approach to protecting critical underwater infrastructure. So welcome to the stage, Jan. Oh, sorry.
Yes. Presenters working? Yeah, okay. Okay, yeah. Good morning, everyone. It's, the best slot between the first coffee injection and the great coffee break. So, I give you just a minute to take the last seats and to adjust the mic. Yeah. Okay, yeah. PROACT was named. The idea today is to present our concept we have shown already during the last days. What situation are we focusing and why are we presenting a concept? So we think the critical undersea infrastructure protection is a complex issue. We learned earlier this morning, and the line, I think, between the civilian and the military perspective is completely blurred in this topic, and this is also from the TKMS perspective. Why is NextGen in this topic? NextGen is our new operating unit. We are usually focusing on civil projects, and there are the other classical branches from TKMS responsible for the military, but in this topic I think the line is blurred. And the Shadow Fleet in the Baltic and the North Sea is known from us almost in the daily media coverage. But nonetheless, I think on the German side, we are seeing especially on the German side how people are looking and just waiting for the Kritis-Dachgesetz, the German Critical Infrastructure Act, on one hand, hoping that this will also regulate the responsibilities between the civilian CUI operators, the federal, the state, the police, and the German Navy. And on the other hand, we are also seeing in this environment that on this issue, the responsibility leads to saying on what is not responsible for and what does not want to take responsibility for. So I think it's not really clear who's really leading in this topic. And this is where I think where we came in and where PROACT is intended to be an approach to proactively move forward and to connect and integrate the most diverse German approaches in the best possible way. As TKMS, we want to lead in this area and we want to lead with such an approach. So why us? PROACT is a 6-phase concept we developed, and we are convinced that we as TKMS, we operate already in the field of naval shipbuilding. I think this is where we are known for. We are operating in the naval electronics as a system integrator, and we are a developer of combined situational awareness pictures. So this is our home turf, this is our home ground, and the integration expertise. We can handle complex technical projects and developments, and reference programs for multi-domain operation and existing CUI projects are already there. The concept, PROACT doesn't reinvent the wheel new. So to be very clear, so we can see it on the next slide. What are the phases? But we contribute to our expertise in this very presented area, and this applies to hardware, software, AI development, and as well as system integration. What you see here on the picture, I've seen comparable pictures also from other companies. I think everyone has nearly the same ideas. We want to build up some smart meshes around critical infrastructure, and we want to put in our assets in the best possible way. So we are a little bit different on the track than other competitors saying, okay, we will just put in a big barrier and throw assets over assets in the Baltic Sea and just have a 100% secure or glassy Baltic Sea. This is not our approach. We want to focus on specific areas where the focus should lie on first hand. Okay. So what's PROACT in detail? So as I said, a 6-phase concept where we put in our knowledge from the company and where we are open to integrate most of our partners and possible partners to join. On first hand, there's a plan. We think we want to start at the early beginning. We want to advise our customers. Exciting point, regardless if we are talking about critical undersea infrastructure, who's really the customer at a later stage, and focus on optimal performance from the outset with regard to the system design. So we think we can help you as a customer, same point, who is it really, to build up a system that really works to protect your critical infrastructure. The R is reconnaissance. I think this is the main focus, building up the situational awareness and the awareness pictures. To do this, we want to determine the status quo of the critical infrastructure in the Baltic Sea, where it's not possible or not available, or we compile existing data with partners to create a proper situational awareness picture. So this is the idea of the reconnaissance. So get in touch with the status quo and see where how the situation is really at these focused areas. The next step is observe. I think this is a really known topic also in this audience here. So we want to have a permanent and constant monitoring, and we want to implement in this phase the classical anomaly detection and consolidation of our integrated situational picture. The next phase is anticipate, and this is where things get excited. And based on the available data we have collected already in the phases before, we want to provide our users with an AI-supported system comparable to our combat management systems, how we use them usually in our submarines and on our surface ships, to best respond to emerging threats. So here we are building on the expertise gained from for example, if we are talking about critical infrastructure in the Baltic, from our static sonar already implemented in the Baltic Sea together with the German Navy, and we want to build up on this knowledge. And we have already running on this static sonar system an AI-based system, and we want to build up on this. The next step is ACT. And here is also the customer topic interesting for us, because if we talk about ACT, there is the line between the possible users of critical infrastructure or the operators compared to a national authority to being in charge, and this is the line between, if we want to decide between lethal and non-lethal efforts to be used for the ACT part. So if we have identified an anomaly and want to respond as a customer, we can draw our expertise in with classic lethal solutions we have from the military domain. I think you can see here torpedoes or what else. We have some ideas what we can do, but we also must respond, as I said, on the non-lethal area, and this can initially involve some kind of reconnaissance or repulsion using AOVs, or that we are that are available on short notice already in the area to just come up and see who's doing something there. But we have also, or we are focusing on some ideas where we can manipulate the maneuvering from the assets coming into these kind of meshes, to some kind of pin down the units in the area. There we are, doing some research on these topics and want to have some options to act on a threat. The last phase is restore. So here we believe in a crisis, the one who can restore the damaged infrastructure as quickly as possible will have a big advantage. And this is where we want to focus on. And here we build on our expertise in maintaining and repairing infrastructure already, what we did, and the repair and the management of complex repair topics we are already faced with all our customers. We want to bring in this expertise and want to work here. As an example, I think down at the exhibition floor, we have a big picture of our ship, the Aquanaut offshore patrol, our offshore vessel, and we want to use our fleet usually used for the submarine trials, also in this critical concept that we can manage offshore the repair activities, or we can do either smaller topics by our own with our ships. This is the idea. So what's really on a glimpse? What's the nucleus of this concept, and what do we see ourselves? So we think we can act as a comprehensive solution provider. We want to integrate solutions, and we are open to other systems. So ProAct, basically, we think, okay, we have much knowledge in our company on our own. We can do much on our own, but we think we want to work together with most of you guys and to integrate all interesting systems on the market. And ProAct is designed open that we can work with everyone together. So we have established expertise. We can trust on our engineering and software development from TKMS and TKMS Atlas Elektronik. We think we have innovative solutions. And we have, and I think this is a good point, this is also something why we wanted to put the SeaCat on the exhibition floor. We have proven saltwater record. And for example, the SeaCat is established for surveying jobs and is already working in sabotage topics. We have the static sonar already mentioned in the Baltic areas with AI analysis implemented with the German Navy. We did some AUV-based anti-submarine warfare last September with the German Navy. And as I said, the Aquanaut is already in place in doing some jobs. And we can use them, or this ship, for example, for the AUV deployment or for repair tasks. And to do it together. This is a short view on this concept. I think it's about 10 minutes right now, not just 5, but I think still in time. And that's it. Thank you.
Don't go anywhere just yet. We do have time for a couple of questions. If someone would like to... Oh, we already have a question. Fantastic. You were hoping for none? There.
Okay.
Peter Menzel is my name. ProAct, there's the word act in it, and you have act at the end, right? So my question to you is now, we are not in war times here, right? How do you think ProAct can be applied to times today? I mean, how can we use ProAct today? Because act is maybe not an option, right?
I think we can. Basically, what do we want to do with the concept at the moment? We want to implement the first phases on first end until mid of 26. We want to go through the first phases. We have ideas for ACT, and I think it lays together a little bit with a legal situation right now in Germany. What and who can really act? We learned earlier today who's responsible to do so. I think ACT is the most interesting part of it. Yeah.
Okay, so this is a vision for 2029.
No.
So that's the whole thing.
I think not 29. I think we should have something in place much earlier.
Thank you.
Thank you. If there are no other questions, I just had one quickly of my own, if you don't mind. I was trying to understand. So you're using all of the technology you already have, all of the knowledge you already have. So what you would like to offer a client, whoever that turns out to be, is a whole service, a whole package?
Yeah, I think it can be. And what I wanted to point out, I think, yeah, we can use much of technology and know-how what we have, but I think there are good ideas outside in the market, and so we want to design it open, and we want to be as open to discuss who can work together with us where possible. So this is the idea right now.
Okay, thank you. Thank you so much.
Thank you so much.
Your notes. And now I'd like to call up here to the stage Florian Schulz, Head of Advanced Development Programs at TKMS Atlas Elektronik. Welcome to the stage to talk about Sonar AI.
Well, thank you, Alex. Welcome everybody to my presentation about, let's say, application of AI technologies or AI approaches to sonar signal processing, which is quite, has big potential to be a game changer if you look at the design of sonar systems and how to evaluate your sonar data. Let's start with this first slide presents you like every AI presentation. It starts with a lot of buzzwords like what is AI useful for, and it's will help the human operator. It can improve the quality of your system. It can speed up the decision process, and so on and so on. And from our experience, these are true, just to be honest on that. And that helps us. These features of AI approaches helps us to set up sonar systems that become more and more optimized, that do not rely on really well-educated experts, which are still hard or even more hard to find in these times, but that can make the life for a sonar operator much more easier and to automate many steps of a sonar system. For the system, the philosophy of the system design becomes a little bit different than before. If you think about a sonar system that is, for example, installed in a platform like a submarine, then you need a sonar operator, and the sonar operator has to operate on broadband detection schemes, narrowband detection schemes, intercept detection, and a lot of different, let's say, analysis functions that only have one goal: to set up the tactical situation display for the commander of the ship. And if you apply, or if you are able to automate many of these steps that are still running in the system, then you can set up a kind of semi-automized tactical or situational awareness display where you only focus on the things that are really relevant for the commander. And that's the which kind of targets are in the sea area and which kind of events are these targets creating. And you can try, I'm not sure if there's a kind of laser pointer, no. You can try to assign events to the different targets and platforms, and maybe you have some clue. Unfortunately, I cannot operate the presentation here. You can click on your target and get more information about the target that the AI has generated. Just to give you a first example, what's possible on sonar data. So we were operating on sonar data for quite some time, applying AI techniques, and you see here on this slide the results, the output of a single channel sonar buoy. So what you see is a typical spectrogram, which is energy plotted versus frequency and time. And you see a lot of events going on. There are some vertical lines, and these are really no acoustic lines, because since these are data from sonar buoys, sonar buoy transmit their data via RF communications, these are disturbances on the RF channel. And then you see some fancy lines going up and down. This corresponds to whale songs. And then more or less in the middle of the picture, you see some kind of ramp going up and lots of harmonics following in the frequency domain, so going up in the vertical, followed by a straight line, which is a CW pulse emitted by an ASW system, and you see a lot of reverberation. If you are interested in what's going on here, you would like to get out the information about the events, acoustic events, and well, classical schemes are just applying energy detection, and that's the result you have on the left side with the red boxes, where we have selected a detection threshold of 10 dB, and every red box denotes an automatically detected event. It's still a lot of events, and there's something detected, something is not detected. But that's, let's say, conventional signal processing. If you apply AI technologies, you end up in the picture on the right side, so it's the same data. But you can clearly see, first of all, the blue box that denotes, oh, there's bio-noise in the water. And then you see the green box denoting there's an active ASW pulse on the water, and even there's a subcategorization possible, which denotes it's a linearly frequency modulated signal going up and followed by a CW pulse. And all other events are neglected because the AI has learned that all the other stuff that is following in the frequency domain, the pulses, is just the harmonics. And all the disturbances caused by the radio frequency channel are marked in the top bar in the, of the picture, and where you see green light, your data is good, and where you have the red light, in RF interference has been detected. This is really useful not only for the human operator, but if you think about the automized or semi-automized system, it requires all this information and should not be overloaded with information that is not useful. So, the change is really remarkable. We have a really increased detection rate. We lower the rate of false alarms. And with AI, you are even able to categorize your acoustic events, which is not possible if you just apply an energy detector. And of course, the AI is not only detecting, but is just ignoring events that are not of interest, like the harmonics of the pulse. Another example, this is from a passive sonar system, which could provide bearing information. And what you see here is a detection list on the left side, plotted detections versus time and bearing. What you see behind in the black and white, that's more or less a detection list. And on this detection list, you let your tracking system operate. And all these nice colorful lines are tracks associated to a certain target. And what you see on the left side is a kind of, well, that's state of the art. That's running in the systems of our customers and looks really good. But the detection list is somewhat reduced because all the tracking algorithms are not capable to follow every single false alarm. If you look on the right side, we have a detection list with an improved resolution, which is hard for the multi-hypothesis tracking algorithms to follow. But a human operator can see much more on these more high-resolution detection lists. And so the idea was, if a human operator can evaluate this, then an AI should be capable of that as well. And as you see here, also with colorful lines, these are tracks generated by the AI. And you can see much more in the AI-generated data. You have more tracks, you have more constant tracks, and this shows you clearly a way to improve your system by applying modern techniques like AI. So I was talking about detection of acoustic events, talking about tracking, and of course you might ask about classification and categorization. This is a topic I cannot talk about here in this audience because we have some cooperation with the customer Navy and we have some patents filed in pending, and I'm not allowed to tell you any more details, but you can believe me, it works as well, like for detection and tracking. And that brings me to my last slide. If you have an automized system that might be able, might have an acoustic sensor and an AIS sensor, for example, and it might generate contacts on the map, and you see every contact that is circled by yellow color, it's generated by the sonar, and every contact generated by AIS is circled with a green color. And basically, as a military, you're interested, is it a merchant or is it a warrior? So is it a threat or is it not a threat? And this is marked in this chart just, for example, by blue and gray, the categorization. And you see there are 4 contacts, 3 of them seem to be merchants. And the 4th one, down right, so in the east of the scenario, exhibits both. And why is that? Well, the acoustics in AIS can derive you a lot of information of the target, like course, speed, MMSI number, and so on. That's from the AIS, and the acoustics allow you to classify, categorize the platform in terms of acoustics. And for these 3 targets, it's fine. They're actually really merchants. There are no warriors. But the 4th one has indication in the AIS that it's a merchant, but acoustics indicates that it's a warrior. And that's not really a strange example, because it really happened a couple of weeks ago in the Baltics that a Russian warship was spoofing its AIS and pretending to be a cargo ship. If your system knows that, an automatic system, because it evaluates sonar and other sources like AIS or radar, this information can also be fused in terms of AI, which is topic of current work at Atlas, just to detect these anomalies. So if a target has, let's say, a label as merchant and a warrior at the same time, there must be something wrong. So definitely something wrong. And this is something where you can also reduce the load of information for operators that were evaluating these big pictures, because typically there are much more than just 4 ships in a sea area like this. And if you can reduce your focus on the targets of interest, that's really helpful. Yeah, and that brings me to the end of the presentation, and I'm happy to receive questions.
Thank you, Florian, for this very interesting presentation. If there is a question, please, by all means, go to the mic. In the meantime, I had a couple of questions. Okay. So one, just to make sure I got this right. So your system both reduces false alarms, increases detection, and also allows fusion of different data. Is that right?
Yes, yes, of course.
In that last example, yeah.
So I showed 2 different examples. One was from the sonar buoy, and one was from a bigger sonar system. And we made the experience with all of the systems. As I said, the buzzwords shown at the beginning, they are true, but nothing comes for free. You need data to train your system, or at least you need to have a good knowledge of data to create good simulated data. But you need to have a good clue of the environment that creates your information. Yes, and it can be fused with other sources of information, not only sonar. Just like the last example that I showed you here. It was just a drawn example, but you can imagine how the system might look like.
Okay. And I saw you mentioned something about training as well of your AI. So I saw there was public information, public data. How does that work when you're selling it to a customer? Do they train it themselves? Do you help them train it?
Yeah, so the example that I showed was from the Redmus trials, and we used simulated data to train the AI, but inferred it to the real data, and we use public databases for that. When we come to the customer, at the moment, the customer provides us data, and we use the data to train the system. But the idea is to set up also, let's say, kind of tooling that the customer himself can train his system further on independent of Atlas.
Okay, so also contribute to saying this was a false alarm, this was, yeah. Okay, great. There are no questions from the audience, so in the spirit of staying within the time, we will end here for now. But thank you so much, Florian. It's been a pleasure.
Thank you.
And now, continuing our presentations, I would like to call to the stage Markus Beer. Chief Sales Officer for Autonomous Underwater Vehicles at EUROATLAS, introducing the oh-so-famous grey shark.
Hello, everybody, ladies and gentlemen. Thank you for having me. It's a pleasure to speak to you. I'm really excited because 200 experts from 16 countries. my daughter made me in the morning this one to have the power. I'm on the other side. I'm really grateful to speak about the latest innovation in the field of unmanned and autonomous underwater vehicle, made in Germany. And okay, I have to speak a little bit more here. And 1 meter 93. Okay. I'm really happy on the other side to speak to you about the latest innovation in the field of unmanned and autonomous underwater vehicle, the grey shark. But before I start with that, I will introduce myself. I'm Markus, you told that. I'm a boy from shore, and as a child I was fascinated by people like you, especially these ones with the impressive uniforms. And I wanted to be one too, and in the year 2000 I made the dreams come true by going to sea on board of a German destroyer, the munitions, focusing on boarding operations, naval diving, and also anti-submarine warfare. And this is the first time where I got deep into sonar technology. And this remained a technical focus up to 2008. And then in the last 16 years, I have held senior sales and business development roles in tech companies, always with focus on naval technology. And now I'm happy to be part of the Grey Shark team and present it to you. But I want to ask you 3 important questions to start before I dive in the presentation. First, who believes in the near future, let's say 2028, where hundreds of autonomous underwater vehicles survey our critical infrastructure? Please raise your hands. I see a couple of hands, but not so much. Sorry for that. Okay, it brings me to my second question. Who believes that acceptance by people will be the biggest challenge? Please raise your hands if you believe that acceptance by people. Oh, it's a good sign. And my last question is, who believes that technology risks are the biggest challenge to have this technology on our critical infrastructure? No hands? Okay, 1 hand. Okay. I think I will take the next minutes to give answers and relevant information to you that explains and that underlines why EUROATLAS and Evologics decided to take their own money to develop this system, and why we strongly believe in that technology. So, but let's start with a general overview to the topic critical infrastructure underwater, and I think mostly or nearly everything is well known because we had discussions in the morning, and I think for years the risks to cables and underwater pipelines were more or less accepted, and it was not possible to monitor all the infrastructure continuous and cost efficient. It was not possible, and therefore we have approximately 200 incidents or faults on underwater cables each year. And if we see we have another thing to be protected, all the critical infrastructure from the oil and gas industry. For example, 20,000 kilometers in the North Sea, 2,400 kilometers in the Baltic Sea. It's really a mess. And we need to protect all that, as well as the wind farms, the offshore wind farms, the oil and gas rigs, and the other stuff. And I think AOVs can change the game a little bit. AOVs can change the game by using their sensors to increase the underwater situational awareness and to deter future incidents by presence. I think it's a combination of many things. I think also the increase of number of Navy vessels in vulnerable areas, as well as using underwater cables as sensors. Yes, I think the gray shark can work as in a swarm, and therefore communication is essential. And I think, as you can see on the picture, it's also important to connect it to my question of the hundreds of AOVs in the underwater domain. It is very important to speak not only from gray shark to gray shark. It's important to speak to every vessel and to have a communication from the ground to the space, from seabed to space. And I think it's possible from technological side, and we should do that. So I think I have to go in this direction. Let's speak about the three most, or I will give you answers on the question, who are the three most important technological innovations that makes the gray shark so unique. At first, I think it's a bionic shape. The second thing is the innovative power package inside. And the last thing is the sensor suite, the advanced sensor suite, and the AI power behind. When we talk about the shape, I heard something, it's the wrong way. I heard questions, is that the Nautilus from Jules Verne? The shape is not made to be fancy. The shape is made. Okay, I will be finished in a few seconds. It's made by Bionic, and it's to have most efficient or energy efficiency and be very maneuverable. The power package inside is a fuel cell variant. We took our nitrogen, oxygen, and hydrogen with us to enable the system to go up to 20,000 kilometers or 10,000 nautical miles. And the last thing, I have to a little bit speed up, is sensors. And I think when we talk about sensors, it's not only the advantage from sensor makers, it's also the combination of information and handle all the data. We have 70 sensors, as Eugene said on the other table, and we have three clusters. Acoustic sensors like our sonars. We have some optical sensors for impressive AI camera and impressive AI cameras that make it real that we can make change detection on critical infrastructure and see changes less than 2 centimeters when we go with 8 knots about the pipeline. And we have the others. And the others means to communicate with satellites, to communicate with each other, and to see where we are. And so far, I'm ready, and and I want to say very thank you for the attention. And this picture is not made by AI. This picture is real, and it was when we were underwater in our daily sea trials. Thank you very much.
Markus, and sorry I had to speed you up, but in the spirit of keeping time, we already have a question.
A very short one. You talked about change detection now. This means you have all the baseline data stored on the gray shark, and you do a real-time processing, and as soon as you find a change, you dive up and give us an information, or how do I understand this?
Yes, if you have the chance to scan the pipeline for first time, you have to be a little bit slower. Afterwards, you can go over there with much more speed, and the change can be can be seen very easy. And therefore, we don't have to go upwards, but if needed, we can go upwards, or speak to other gray sharks and other lines, or to a buoy or go to the surface and send the information to the satellite.
So it means I can upload my baseline data, which I have surveyed before, or do you have to survey it by yourself? Means we have baseline data from infrastructure. Can I upload all my multi-beam data to the gray shark?
Yes, you can upload that. You can give us all your information. It's very helpful, and therefore we are pleased to connect later on. And
Thank you. There's a second question also.
Yes, hello, thank you very much. A very impressive vehicle. Per Fitzek, I'm from Kongsberg Discovery. I would like to know when you are expecting this unit or this vehicle to be ready and brought it to the market. Thank you very much.
we will be happy at we will be ready at the end of this year with the battery-driven one, and at the beginning of the next year with the fuel cell-driven one. We have two different systems.
I'm happy to be ready.
Okay.
So just one quick question from me. The underwater domain is notoriously difficult in terms of communications. So how are you managing the whole connecting with other systems? Is it going to surface to communicate, or can it communicate underwater?
Underwater, it's always acoustics, and therefore we have an acoustic modem to speak, for example, with the other underwater vehicles. And from time to time, you have to go to the surface and send the mass of data if you have, and if you need to send, via satellite. We have satellite communications in the aft section of the vehicle.
Okay, so when you're communicating underwater, it's small bits of information, it's the process data on the system, and then satellite, it's the package, as you said.
Yes.
Okay,
of course.
Perfect. Thank you so much. Thank you, Markus, for this.
Thank you.
And now, last but certainly not least, Dirk Pettis is going to come here on stage, Policy Officer at DG Defense, Industry and Space at the European Commission, to explain to us the role of DG DEFIS in the context of developing technology to protect critical maritime infrastructure.
Yeah, this a clicker? Good. Yeah, good morning, distinguished audience. First of all, I want to thank you for inviting me and for providing the opportunity to speak to you. I will probably come from a little different angle than my predecessors, not so much technically, but I will try to explain the role of the Commission in this context. So, first of all, here's basically the command intentions that the new Commissioner Kubilius got from the Secretary General, and that makes it quite clear that there are three main tasks. And within these tasks, as you can see, number 3, pool resources and counter common threats through flagship European Defense Union projects. One of those flagships, they were actually kept kind of secret so far, but fortunately we managed to have the one relating to maritime domain awareness, published and referenced now in the context of the Ocean Pact that has just recently been finished by another DG. And so basically the Commissioner is very determined, I can tell you. In the white paper we are also addressing specific areas, and the protection of critical maritime infrastructure certainly is one of the most important things that we are dedicated to achieving. Having said this, the Commissioner basically assumes, because I heard this morning, what is the situation right now? Seriously, SecGen and the Commissioner are quite clear about this. We are in times of pre-war. This is not peace anymore. We see, particularly in the maritime domain, constant attacks. And I believe that you have, and they are going on all the time, hybrid attacks. And I believe that you've had several briefings to that effect. And there's also no doubt to whom they can be attributed, to possible, how shall I say this, to possible aggressors. And because of that, we need to react. And the view, different to what I hear in Germany, the view from the Commission and also from the SecGen is that we do not have any time to lose. We do not take 2029 plus as guideline, but we figure we have 1.5 years from now at the most to be ready. Therefore, they do expect tangible results. This is why we come, how shall I say, from a result-oriented approach. We do say, of course, you do need research and development for a long-time perspective, and we do set up several projects and programs to that effect. I will show those shortly. But at the same time, we need to be aware we need to do something now. And because of this, we also need to come to very pragmatic results with regard to who's doing what and who's responsible. That should not prevent us from achieving something. And another thing, what is the role of the Commission in general? Obviously, it is the member states, different to public belief maybe, it's the member states that are in the driver's seat. The member states determine everything we do. They provide the money, they set the targets, and they tell us basically what to do. What the Commission does is, we try to facilitate member states' united desires, if you will, and we come up with proposals to that effect. Now, if you look at all the projects we are funding, you will see here there's plenty of them run by many different entities to mitigate the risk to critical infrastructure. And that's actually, on the one hand, that is very, very good that you see so many actors trying to do so many things. But that brings us also to one of the key challenges in this context, and that is that the things aren't necessarily connected. And you know, in the context of innovation, to use this very practical example, I had the pleasure to be invited to the Distinguished Visitors Day of the CSEC experiment that was presented earlier this morning. An excellent approach, by the way, because it is just like a hands-on thing where people say, okay, now we are trying to actually achieve something. We will not show slides, but we will deliver hand-on solutions. In that context, Peter Terspiga, one of the leading company officers of Damen shipyards, he asked the Navy kids that were experimenting with all this stuff, and he said, so what do you think, what do we need to improve most in terms of, you know, practical approach? And they said, well, sir, you know, each of the technical solutions presented here are super, as they are. The only thing that we are missing is their integration. It's their integration and to make sure that they all relate to each other, because it will facilitate their employment and also our training. Otherwise, we have to learn everything from scratch for every new device. So from point of view of the Commission, all the technical solutions we are seeing here are a means to an end. We come from the approach we want to achieve maritime domain awareness and, as set out in higher political guiding documents, maritime security in Europe. And for this, we need to find the best and the most innovative solutions. And usually, what can the European Union do? Well, normally we throw money at the problem. But I think we can bring something more to the table. And this is like, as you can see here, in the current European Defence Fund that has been originally set up with 8 billion euros for 8 years, there are critical areas and underwater warfare that would cover the protection of critical underwater infrastructure is covered. And as you can see, in an annual work program, the naval work overall gets usually 10%, a little more than 10% of the whole show. And here in underwater warfare specifically, we have 2 projects that get in research and development that do get funding. Now, there are several categories of actions covering the areas shown here, and there are some main expected outcomes, just to give you an idea of what we are specifically trying to promote here. First, prototype of a modular mine countermeasure suite, then prototype of an unmanned anti-submarine warfare seabed warfare solution, then the development of manned-unmanned teaming systems for multiple mission types, and the testing of an extra-large UUV. But having said that, these are all technical solutions, and they are important, and I'm sure that quite a few of you, representatives from the industry, are already involved and are looking forward to getting involved further. Let me assure you, there will be much more money on the table, so that should catch your interest. But we should also not forget, money alone doesn't do it. Actually, for the most part, what we need now is common sense. The common sense, like I said, to connect what we already have, and that starts in surveillance. It starts in maritime surveillance, and it goes all the way to the employment and the connectivity of all the means we have. So if you take one look, we would like to see maritime surveillance capabilities. These are specific projects. I don't want to go into detail because there is no time for it, but you can find the fact sheets online that will show you some of the projects we are already sponsoring. At the end of the day, and this is what is actually covered in the flagship project reference in the Ocean Pact. We need to achieve a maritime domain awareness that will ensure something like a glassy ocean, a perfect picture from space to seabed. And this should be done in a three-step approach. The first step is actually to deliver results within 1 or 2 years by basically connecting the systems we already have. Number two is, and that focuses on the surface. Number two is to add the underwater layer. And for this, I'm very grateful to hear all about the efforts that you're all pursuing here and that the solutions you're presenting. And in the third step, we need to find out a way to connect this to space to really make sure that we are aware. Because from our point of view, the one thing we cannot do is tell the European citizens, well, you know, we could have known about this MS Ruby being loaded with so much ammonium nitrate headed towards the Union or somewhere else, causing greatest damage, but because we couldn't agree on sharing the information and passing it on to the relevant actor, we didn't stop it. No, this is certainly not the approach we are taking. And that's why I'm saying we need to be pragmatic and we need to find a way. And this also requires, for example, as we call it, interoperability and interchangeability, ideally, of systems. And for this, and it all starts with a picture. All naval officers know a recognized maritime picture, so you need to know your own forces, you need to know about the white shipping, and the red forces will enable you to act. Here in underwater warfare, you see some further projects that address specific aspects of this, and I think they are all fairly useful. But again, we also need to encourage, in particularly the German industry, to become involved, because what we do see is that while there's a lot of money and Germany pays, if I can say this, 20% or so of the budget, we would of course like to see the support of the German industry in the same way. And unfortunately, we are not really equally represented there. So there's room for improvement, and I hope that the government will support this. And also we do need the ingenuity of the people here. And that is also in terms of innovation. What does that mean for us? Well, when we want to find the best talent, the brightest people to support us, we asked, like, how could we gain their support? And they said, well, if you offer us a career in the Navy or so, we will say, no, rather not. If you ask us, can we help you track Putin's yacht? We are all for it. You know, and in this context, we try to find those people in these projects, because the way our projects are designed is that you usually want to focus on small and medium enterprises, on startups, but connect them to the larger companies. And that is also something, for example, we have seen in CSEC, where that worked perfectly in the context of the Northern Naval Capability Corporation, where after people work together for 3 or 4 weeks, this is just fine. This is actually one of my projects, if you will, a comprehensive underwater information intervention system that is actually there for divers, and it could also serve as a blueprint for underwater communication at a small scale at depths. Okay, I got to speed up here. Yeah, there are some other projects. I don't want to go into detail. Here, I can share the slide. Here you find the useful links to our projects and programs. Slides shall be provided, not a problem. And here, for example, you see what is going on in 25. For the most part, it's been done already, but the important date is mid-October, deadline for submission of R&D proposals from the industry based on the call for proposals that we have launched a little earlier this year. Yeah, and I hope that gave you a first impression. Thanks a lot for your attention. I hope you didn't expire before I did, and ready for a question if you have. Thank you.
Thank you very much for this. And we already have a question. I do like when we have very engaged audience members.
Hi, Peter Menzel from Corvus Works, and I have a very short question. I heard what you were saying about this 1.5 years, and the only solution you maybe have is just throwing money on it. You have another one. But we are talking about new technologies, means things that are coming from startups, small companies, right? Mm-hmm. Like we are. And within the last 10 years, we developed really important key technology for MCN, which is not funded anymore, no, because it was scientific research. And now there's no way to get any funding, actually, so that we had to send our stuff home, and the knowledge is now lost forever. So we have key knowledge within the companies, not ours, just also small companies. We have startups here in Germany, and the key knowledge is lost because the money get not released within short times. I mean, the 3 times horizon, 3 years of time horizon is not acceptable for a startup. So is there any way to also accelerate this in any way?
Yes, that issue is actually one of the key lessons learned from the past EDF, that the smaller companies are telling us, Dirk, you know, to apply for one of your grants, it takes about 400 man-hours, and it takes at least, like you said, 2 years or so to actually get to the funding, and that's too long. That's why we have created what is called EURIS, European Defense Innovation activities that basically focus around 5 work strands where this is much faster. Also be assured that in the upcoming instruments, EDIP, European Defense Industrial, the implementation of the European Defense Industrial Strategy, it's supposed to be, it will go to the Council hopefully in 2 weeks or so, a little less than 2 weeks. And there we will also try to devise instruments that will address this issue, because we do understand it's a key problem. And one line in this context, for me, the biggest lesson learned from our past projects is this. When we see all those projects, you know, they're all super ideas, but there's one thing from my point of view, from a naval background, that's missing, and that's a plausibility check, asking, what do all of these results, of these projects' results, first of all, contribute to mitigate our critical shortfalls? Nobody's testing for that, number one. Number 2, what we are definitely missing is the end-user dialogue, because defense is a closed market. So if you finish a project, you have a project result, not a product, let alone a capability. And if you do not get the buy-in from member states, that somebody, like you were saying, you produce a result, but nobody's picking it up, then it's lost. So we should make sure that we have the end-user dialogue from the beginning. And like the Northern Naval Capability Cooperation is a very good initiative in this context, where you actually bring, because this is something that struck me as odd in the Commission, like uniforms are not liked there. You know, everybody comes from a civilian background, and they always look at the industrial base. They look only at the industrial point of view, and that is a good thing, but you need to connect it. If you want to achieve something, you need to connect this to the requirements and to the demands of the member states, and to find a way to jointly reply to this.
Thank you. We have one last question. A challenge to you both. 1-line question, 1-line answer.
I'm like Dr. Lee, writer on naval issues. My question is, one of the items discussed here in the conference was data fusion and data analysis. Is there some support available from the Commission?
Yes, as a matter of fact, there is. I'm not entirely sure how releasable it is at this stage, but let's put it this way. There is a member states initiative to create like a memorandum of understanding for the protection of critical infrastructure in the Baltic Sea. And the European Union, at first they said, no, we don't do MOUs, now we will. And this will actually, that will actually ensure our access to the resulting network. Because we believe, also in a nutshell, there's only one recognized picture. And the resulting information needs to be delivered to the authority that is responsible to act. With no, and the Commission has no idea, no intent to change the scope of authority of anybody that may be different in any country. We don't care. But the information needs to be available for those that do it. And be this in the context of a United Nations, a NATO, or an EU operation, whatever that may be. Like I said before, we can't tell the citizen, well, you know, because we couldn't agree on how to do this, we failed to properly respond. That's not acceptable.
Perfect. Thank you so much. Thank you to all the presentations that we've had for this technological innovation. And we have the break now, and we have to be back in, well, Terry will know. But thank you again.